Can you please confirm that you can hear me? Assume that I'm audible. So I'm sharing my screen now. Yeah. So in last session we discussed about variables. We discussed about variables. So we discussed about the classification of variables, and we also discussed about the scopes of the variables, the scopes of the variables. So we discussed what is an instance variable, what is a static variable, what is a local variable. We discussed what is a static, what is instance, and what is local variable. Okay. So the variables are of we have primitive variables, or reference variables. We have reference variables. When it comes to the scopes, based on scope, we have instance or object level variables, we have static variables, and we have local variables. We have local variables, right? So instance variables changes from object to object. Instance variables changes from object to object. Static variables are like a common for every object. Common for every object. Okay. Local variables we need for temporary access, for temporary activity. Temporary activity. So one thumb rule to remember here. One thumb rule to remember. Okay. Either it can be instance or static. These will be instantiated by your JVM. So the default, if you don't provide any value to the static or instance variables, your JVM will give the default value. Your JVM will provide the default value. But for local variables, the developer is responsible to pass the value to them. Okay. So JVM will never initialize, or JVM will never initialize the local variables with default values. Okay. So the local variables means it can be inside a loop, or inside a method, or as a method parameter, or as a method parameter. So if you are using any local variables for temporary reason, the developer is responsible for initializing these variables. Initializing is simple to say assigning some value or storing some value inside the variable. So local variables, JVM is nowhere responsible to allot the default values. In case of instance and static, if you are not assigning any values, JVM will by default will pick a default value. JVM will pick the default value. So it is the same for primitive or reference variables also. Primitive or reference variables. For primitive variables, okay, the primitive variables which are of instance scope, which are in the instance scope, then as per the data type, the default value will be assigned. The primitive variables which are in instance scope, okay, the default values as per the data type will be assigned. Okay. For reference variables, the default value null. Okay, the default value, it has only one value which is called null. Only null value will be updated by the JVM. In case if you don't provide any values to it. Okay. So a primitive variable which is an instance scope or a static scope, who's responsible? Your JVM is responsible to allot the default value. Similarly, the reference variable which is in instance scope or a static scope, your JVM is responsible for that. But for local variables, the developer is responsible. Okay, developer is responsible. Okay. So that is about the variables concept. Now there is something special called, okay, there is something special called constants. There are something special called constants. Okay. So variables means the value will be changed. The value will be changed at program at any point of time, during program execution. During program execution, right? So constant means the value will not get updated. The value will not get constant means fixed. These are fixed. Okay. So constants also comes under the variables only. These are called as, okay, it's a special variable. Constants is a special variable whose value can't be modified. Okay. Constants are also variables only. Constants are these are special variables. These are special variables where values once assigned values once assigned will never change. Will never change at any point of time. At any point of time during program execution. During program execution. Okay. So so constants are also the special variables, which means the values inside these special variables will never change. Once the values are assigned, they are fixed. They are fixed. So constants are called as final variables. Constants are called as constants are called as final variables. These are called as final variables. Okay. Once the value is assigned to that constant variable or to the special variable, final variable. Okay. Then in program you cannot modify that value. In program you cannot modify that value. Okay. So 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 are the constant variables or the final variables. Once the values are assigned, then nobody can change the value. Nobody can change the value. Okay. So there are another rules also. A variable that is declared, a variable declared, okay, as final. A variable that is declared as final and not initialized. And not initialized. You just declared a variable, but you didn't pass the value. You didn't pass the initialization means assigning some value into to the variable. Assigning or storing the value inside the variable is called as initialization. Okay. A variable declared as final and not initialized. Those kind of variables are called blank final variables. Blank final variables. Okay. You just declared the variable, but you didn't assign the value. You didn't assign the value. Then this is called, then it is called, okay, then it is called blank final variable. Blank final variable. Okay. So one thing to remember, one thing to remember. So constants are special variables where values once assigned, they cannot be modified at any point of time during the program execution. So constants are called as final variables. Final variables. So any variable that you declared as final, and if you don't assign some value to it, if you don't initialize the value to it, then they are called as blank final variables. The last rule, okay, your compiler does the optimization. Okay, compiler is very intelligent. It is not just, it will verify the syntax or it will check for the grammar or something like this. So it will scan your code and it will identify the final variables in the code. It will identify the final variables. So so your compiler your compiler will scan for will scan for your compiler will scan for final variables, and the, and the variables are replaced with and the variables are replaced with actual values that you assign. Actual values that we assign. Okay. So what does your compiler do is it look for the final variables in your code. It look for the final variables in your code. And if a final variable is found, okay, a final variable is found. And if you are using that final variable somewhere, okay, instead of using the variable, it will replace the actual value there. It will replace the actual value. Why it does that is why it will actually replace the value is to optimize the memory. To optimize the memory. We know that the constant value, the final variables means they are fixed. There is no change. Value will not be changed at any point of time. Value will not be changed at any point of time. This is fixed value, right? So in such case, why I have to assign some, why I have to allot some memory for it? It's always fixed, constant value. Say constant value, right? So so why so instead of allotting a memory, and storing that value inside it, the compiler what it will do is it will does the optimization. It does the optimization. What optimization it will do is what optimization it will do is during compile time, during compile time, okay, your compiler will scan for the final variables wherever you are using the wherever you are using this final variable, right? Wherever you are using the final variable, instead of the variable, it will use the value directly. It will use that value directly, so that no memory will be allotted for the final variables during program execution. During program execution, that's the optimization. Your compiler does that. Okay. So these are the four rules. So constants are the final variables. Constants are the final variables. So the values once assigned for a constant variables, they cannot be modified at any point of time, and and variables that are declared as final. Variables that are declared as final. And if you are not assigning some values, they are called as blank final variables. Blank. Can you guys see my screen now? Can you confirm over the chat? Can you confirm that you can see my screen and you can hear me properly? Hello? Am I audible? At least. Hello? Can someone confirm that you can hear me now? Am I audible? Okay. Thank you. Thank you for the confirmation. Sorry, there is a network outage from my end. So that's the reason. So assuming that now my screen is also visible to you. So We'll define the final variable. We'll define a class now. We'll write a small program for defining the variables and for defining uh, the final variables and one small test for the constants. We'll do one small test on the constants. So we'll take this new text document. So we'll name this class as final check. We'll make this class as final check. So I have a main method, and what I'm doing is I'm defining a final variable. Okay, I'm defining a final variable a, and I'm assigning some value to it, and I'm assigning some value to it. So now, how to declare the final variables? Just you use the final keyword in front of the variable name. So you have a data type. This is how you declare the variables. You have a data type and you have the name of the variable and some value and some value, right? So how do we declare the final variables? Just add final keyword in front of it. If you just add final keyword in front of it, then then this becomes a final or a constant variable. So now what I will do, I'll just try to print this variable. Println of a. So here a is nothing but the variable. It's a constant. It's a special variable, which is a final variable. A is a final variable. Now, when it tries to compile the code, then this value, this a will be replaced with 99. A will be replaced with 99. So let me save this code. I'll save this code as finalcheck.java. Finalcheck.java. So I have the Java file here. So I'm opening the command prompt. I'm trying to compile the code. Java C finalcheck.java. Code has been compiled. Code has been compiled. Now, if you see, there is a dot class file. There is a dot class file. Now let us try to download a special software which is called Java Decompiler. So Java Decompiler is one software which is used to just to you know to read the binary code. To read the binary code. Let me try to download it. So it has been downloaded. Java Decompiler. This is one software where we can convert our Java dot class file to a source code again. So I'm opening a file here. So it's in my this PC, Windows, Anil practice. So in this, I wanted to read final check dot class. I'm opening this. You see now, this is the compiled code. This is a dot class file. Using actual code, if you see, this is the actual code. I have defined a variable int a equal to 99, right? A final variable which is called a equal to 99. But your compiler is so smart. It is so smart. What it has done, it has removed this line in the code. If you see the dot class file code, so which is converted. Okay, this is the binary code. This is the byte code which is generated by your Java compiler. So final check dot class. This is the binary code. So using Java decompiler program, I'm just reading what it has generated. What is the logic it has generated? Java decompiler is one of the program which can read your bytecode and convert to the source code again. It can convert to the source code again. So after optimization, you see there is no variable inside the code. After come in the bytecode, if you see the variable whatever we declared, final int a equal to 9, this line is no more available. This line is no more available. What it has done, it know that okay, it's a final variable. It's a final variable. So declaration of this statement will add a weight to your program. It will add a weight to your program, which means it has to allot some memory for this variable, right? So int means 4 bytes of memory it has to allot inside your memory by your JVM, right? Your JVM has to allot some memory for it. So for constants, I know that these are constants and they will never change in the program. So instead of allotting the memory, your compiler itself will optimize it. Your compiler will optimize it. It will remove this line completely wherever you are using that, wherever you are using that variable, there it will replace with the value. There it will replace with the value. So this is what I was talking about. So your compiler is very smart. It does this optimization also. So the final variables are replaced directly with the values. Whatever the value that you give, this value will be replaced wherever you are using it. Wherever you are using it. Okay. That's about constants. That's about constants. Constants are very simple topic. They are special variables or which are called as final variables. So the values once assigned to the variable in any time or at any point of time, if you try to change it, then you get compile time errors. For example, I'll close this decompiler program. Now here already the value is being assigned. So 99 is the value which is already been stored in A. Now I'll try to change the value of A again. So now A equal to 101 I'll say. So instead of 99, I'm changing the value to 101 in the next line. In the next line. Okay. And I'm trying to save this. I'm just saving this. Now source code is been modified. Again, I'll try to compile it. Again, I'll try to compile it. You see that, okay? So cannot assign a value to the final variable A. So once the value is assigned, if you try to update the value again, your compiler will give you a compile time error. It will give a compile time error. So you cannot assign a value to a final variable. Okay. The name itself says that this is final. The value is final. Okay. You cannot update the value inside a final variable. Okay. So you cannot modify the values inside a final variable. Okay. Only value assignment will happen only at one point of time. Only at one point of time. Okay. So I'm making one more change. Simple. I'm just defining the variable int final int a equal to final int a. I'm just declaring the variable. I'm not passing any value to it. I'm not passing any value to it. And I'm just saving this. Control S. Okay. You go for control save. You just save this. Now I'll try to compile this code. The code has been compiled. The code has been compiled. Right? You see that the code has been compiled. Okay. So which means this is a blank final variable. This is a blank final variable. Variable is just declared. There is no value inside it. There is no value inside it. So the blank final variables when you declare, okay, at least in the next statement, okay, in the next statement you have to assign some value. You have to assign some value. Without assigning the value, if I try to use this, okay, I am trying to print it now. I'm trying to print it now. So this is a final variable. There is no value inside it now. I didn't pass any value inside it now, but I'm trying to print the value inside it. I'm trying to print the value inside it. Now let us see what happens. I'll try to compile. You see that, you see that you get a compile time error. You get a compile time error. So when you are, a variable might not have been initialized. When you are defining a variable, a blank final variable, if you are using that variable, if you are using that final variable, you must have to initialize it. You must have to pass some value to it. Okay. Yeah. If you don't pass the value, your compiler doesn't know what value it has to use there. What value it has to use there. Right. So at least in the next statement, you have to pass some value to it. I'll try to run the code. Class name is final check. What is the class name it has generated? We'll go and see that. It's caps. C is caps. $20, right? So now if you open up the Java decompiler and see what is there in that. Go to the downloads, open the Java decompiler program, try to open the file. You see this. Now you see this. We have declared integer type. We have declared integer type. You look at our code. It is of integer type, right? It is of integer type. But if you see here, it has converted that to a byte type. It has converted that to a byte type. Okay. So in case if you are declaring a blank final variable and if you are assigning some value and if you are assigning some value in the next line, okay, as per the value that you pass, as per the value that you pass. So it will optimize it. Okay. Instead of, so 20 can fit in the byte. So why it should waste 4 byte of memory? Okay. Where the 20 value can fit in one single byte. The 20 value can fit in one single byte. So for the blank final variables, internally your compiler will turn that to a different different data type. Different data type. So your compiler not just, it will not, it is so intelligent, it will not compile the code or it will not check for the syntaxes. It will not look for the uh, rules and regulations of the program or recommendation. It does the optimization of the code also. It does the code optimization also when it comes to the final variables. So this way it reduces the memory of your program. Okay, if you are using variables with huge length and uh, huge huge variables, if you are using, it will optimize it as per the data type that you are using, as per the value that you are assigning to that, as per the value that you are assigning to that variable. Okay. So compiler does the code optimization also. Compiler does the code optimization also. When they are blank final variables, which means the memory will be assigned for your final variables. But internally, it will not be treated as a final variable. Internally, it will not be treated as a final variable. Okay. If it's in a single line that you do, if you do that in a single line, it will completely remove that line and it will directly use the value. If you are using a blank final variable, so based on the value that you give, okay, based on the value, for example, if I'm giving here 200, okay, if I'm giving here 200, the value as 200, and I'm trying to compile this code again. I'll close this. 。 . 。 . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . code has been compiled. Now I'll open the Java decompiler again. I'll open the file again. You see now, it has changed because byte range is minus 128 to 127. Byte range is from minus 128 to 127, right? If you know the byte ranges, the range that we discussed, what is the range of a byte, right? What is the minimum value? What is the maximum value? That's the reason I told that table is very important. Okay. So, so now if you see here, so I'm declaring an integer type. I'm declaring an integer type and the value that I'm passing is 200. The value that I'm passing is 200. But if you look at the byte range, it can store only up to from minus 128 to plus 127. So, but the value is with out of range. It is 200. It is more than 127. It is greater than 127 number. Then what it has done, it has chosen the char. It has chosen the character. So the reason why it has chose the character is, okay, if you see here, so there is some special character, there is some special character, and this value is 200. This value is 200. Okay, so internally it will represent a character for you. It will represent a character for you. But when you try to print the actual value, okay, what is the uh, Unicode value of this character? That value will be printed here. That value will be printed. So your compiler does the code optimization. Your compiler does the code optimization. Okay. Any questions on this? So just remember, the final variables are fixed variables, or these are the constants in Java. If you want to define constants in Java, you have to use the final keyword. You have to use the final keyword. In case of blank final variable, memory will be allotted by your JVM. Memory will be allotted by your JVM because compiler does the code optimization. Compiler does the code optimization. Okay. But if you are initializing the final variables in a single line, directly the values will be replaced. Directly the values will be replaced. Any questions on this? Any questions on constants? Assuming there are no questions, then I'll write a small program here. I'm expecting some output from you guys on this program. So here I have int a equal to 99, int b equal to a, int b equal to a. Then I'm trying to print a value and b value. After that, I'm changing the value of b to 88. Then again, I'm trying to print a and b values. But this time, I'll use a separator in mid. So can you explain what would be the output of this program? సేమ్ మేఘ ఫైనల్ ఇంట్ ఏ అంటే అవుట్పుట్ లో బ్లాంక్ వేరియబుల్ కదా. వై ఇస్ ఇట్ కమింగ్ యాజ్ బైట్ ఆర్ క్యార్? ఓకే, సి ఇక్కడ ఇక్కడ ఏమవుతుందంటే వెన్ ఐ సే ఇంట్ ఏ, రైట్? ఓకే, ఐఎమ్ సేయింగ్ ఇట్ యాజ్ అ ఫైనల్ వేరియబుల్. ఫైనల్ మీన్స్ కాన్స్టెంట్. వాల్యూ ఏమి ఉంది ఇక్కడ? వాట్ ఈస్ ద వాల్యూ దట్ వీ హ్యావ్ హియర్? Compiler has to know the value, right? What is the value that you're passing it to it? It doesn't know. We are not passing it. We are not passing any value to it, right? We are not passing any value to it. So now what it thinks is, okay, he wanted to define a variable. So it is assuming that he wanted to define a variable, but he defined a final variable, a blank final variable. Okay. So now, based on the value that you assign it here, okay, బేస్డ్ ఆన్ ద వాల్యూ, ఈ ఏలోకి ఏ వాల్యూ అయితే పంపిస్తారో ఆ వాల్యూ ఏ రేంజ్ లో ఉందో చూసుకుంటుంది అది. విత్ ఇన్ 1 బైట్ రేంజ్ లో ఉందా, లేకుంటే విత్ ఇన్ ఇంటీజర్ రేంజ్ లో ఉందా, విత్ ఇన్ లాంగ్ రేంజ్ లో ఉందా? వాట్ ఈస్ దట్ రేంజ్? ఇంటర్నలీ యువర్ కంపైలర్ విల్ వెరిఫై దట్ ఫర్ ద రేంజెస్. ఓకే, సో ఇప్పుడు నేను ఫర్ ఎగ్జాంపుల్ ఏ ఈక్వల్ టు 20 అని ఇచ్చాను ఇందాక యూస్ కేసులో. ఏ ఈక్వల్ టు 20 ఇచ్చినప్పుడు అప్పుడు అప్పుడు మెమరీ అలోట్ చేస్తుంది. బ్లాంక్ ఫైనల్ వేరియబుల్కి మెమరీ అలోట్ చేస్తుంది. మెమరీ అలోట్ చేస్తున్నప్పుడు int will take 4 bytes of memory. Your JVM will allot memory for blank final variables, but how much memory it will occupy? 4 bytes. It will occupy 4 bytes in case if you are giving it as int, right? Now why I should give 4 bytes where the value can store it only in 1 byte, right? It will look at the range of that number or the value that you're passing. As per that, it does the optimization. Your compiler does the optimization. What is best suitable for that value, that data type it will pick. Okay, nowhere it will print blank. It's a blank final variable. Final variable అనేది ఎక్కడ ప్రింట్ చేయదు. ఇట్స్ ఎ కాన్సెప్ట్. బ్లాంక్ ఫైనల్ వేరియబుల్ కాన్స్టెంట్ అనేది ఎలా కాన్స్టెంట్స్ అనేది ఎలా కాన్సెప్ట్, వేరియబుల్ అనేది ఎలా ఒక కాన్సెప్ట్, బ్లాంక్ ఫైనల్ వేరియబుల్స్ అనేవి కూడా ఒక కాన్సెప్ట్ ఇన్ జావా. ఇట్స్ ఎ కాన్సెప్ట్ ఇన్ జావా. Okay. So now don't look at the identifier. Identifier can be anything. The class name can be anything. You look at the logic now. Look at the logic. The logic to see what would be the output of this program. Can someone tell me what is the output of this program? Int a equal to 99. So int a equal to 99, and I'm saying b equal to a, and I'm just printing the a value and b value. Then I'm changing the b equal to 88. B equal to 88. I'm changing the value from b equal to 88. And now after that I'm trying to print a and b. What would be the output? If anyone wanted to speak, then unmute yourself and you can talk, or over the chat you can give me the answers. Can someone answer what is the output of this program? Int a equal to 99, b equal to a, printing a and printing b. Guys, can you please unmute and answer, please? At least we expect some response. Whether it is true or false, it's secondary. I want people to be more proactive in the class. At least, yes, we can answer this or we can't answer this. Expecting some answer from you guys. Very simple program. Okay, as simple as it. Assuming that you okay. So here I'm saying int a equal to 99. Int a equal to 99. So now inside a, the value that is stored is 99, right? Something like this. You always has to okay picturize the memory concept. Picturize the memory concept. How your JVM will execute this. How your JVM will execute this. What you have to do is you look at the program. You try to draw the memory picture for this. So the logic that we have written is int a equal to 99 and int b equal to a. Then system.out.println of a, system.out.println of b. And then we are using a separator. Then we are using a separator. Then again b equal to 88. Then I am trying to print a and trying to print b. This is the logic. So now inside memory, inside think this is your memory allotted for your program execution. Your JVM got this memory from your computer. JVM has got the memory. Okay. So now the variable name. What is the name of the variable? A. The variable name is A. And the value, what is the value? 99. It stores 99 here. So now when it comes to the next variable B, the name of the variable is B. Name of the variable is B. So B equal to A. B equal to A, I'm saying. So already inside A, we are just copying the value of A to B. We are just copying the value of A to B, right? So 99 is inserted into A, and the value of A we are copying into B. The value of A we are copying into B. Now the value will be 99. 99. So when you try to print A here, the value will be 99. When you try to print B here, the value will be 99. After that, you should get a separator. Now, after that, what we have done, we are changing B value to 88. We are changing the B value to 88. So now what happens? Someone has answered B equal to 99. Okay. Now, so now B value we are updating it to 88. B value we are updating it to 88. So which means whatever the value that is there inside your B, that will be overridden. So it will erase this. Erase means only the value it will remove, not the memory. Okay. So it will previously it has 99. Previously it has 99. Now it will remove just this 99. And what it does is it will replace that 99 value with 88. It will replace the value with 88. So in this case, so the A still has 99 value and B has 88. So the output will be 99, 99 in the first case. After modifying, A value will be 99 and B value will be 88. B value will be 88. Exactly. That's correct. So let us see that. I didn't close this. Second brace has to be there. The closing braces. Problem with the closing braces. Code has compiled. 99 and 9988. Okay. Now, so these are local variables, right? Int a and b are local variables because I'm defining them inside the main method. So any variable that is declared inside main method or inside any method, it's not main, inside any method, right? Any variable that you declared inside a method, they are local variables. They are local variables. Now these variables I'll define outside. I'll define outside and I'll make them as static variables because static, so instance variables you cannot directly access from static context. From static methods, directly you cannot access instance variables. For example, if I try to give this, then you will get a problem. You will get a problem. Now if I try to compile the code, see, so a non-static variable cannot be referenced from a static context. So instance variables you cannot access from the static methods. You cannot access from the static methods. Okay. So if you give the static keyword here, if you give a static keyword here, then you can access them. Because the variables are static, they are common, and the method is also static. The method is also static. So the static variables are only can be referred from static methods. Okay. So now the code has been compiled. The same output, right? But this time I'll not assign any values to this. I'll not assign any values to this. This I'll make it as float. This I'll make it as float. So now these are static variables. These are static variables. And these are static variables and they are defined outside the methods. Nowhere inside any loop or nowhere inside any methods we didn't define them. So now who's responsible for these variables to initialize is, okay, who's responsible to initialize these variables is your JVM. Now JVM will automatically, since we have not given any values here, your JVM will automatically will assign the default values for it. Okay, it will allot some memory and allot some, it will assign some default values. Now let us try to print this. Compile the code, compile successfully. The class name is capital C. You see this. I didn't give 0 or 0.0 in my code, right? For integer, what is the default value? 0 is the default value. For float, the default value is 0.0, 0.0, right? So it is printing the value, it is printing the value which is defaultly assigned by your JVM. But if I give the same thing, inside the method, if I do the same thing inside the method, now these becomes the local variables. These becomes the local variables. So because they are defined inside method, they are defined inside a method. Now, who's responsible to initialize these variables? The developer is responsible for initializing the variables, not by a JVM. So now this time when I try to compile this, see it, your compiler says that variable A might not have been initialized. Boss, you declared a variable which is a local variable, but it has not been initialized. You're trying to use it. You're trying to use it. Okay. So your compiler says that it's a local variable. So local variables must be initialized by the developer before you use them. Before you use them. If you're not initializing them, then compiler will definitely say no, I'll not compile the code. Okay, it's a thumb rule. So for local variables, the developer is responsible to initialize the variables. So let me give this as 20. See, I gave the value as 20, it is adding 0.0, 0.0. So the decimal values will get updated. Okay, since it is float type, 0.0 has been added. I didn't add, it automatically added. Okay, that's about constants and variables. Any questions on this? No. Okay. So in that case, can you tell me the output of this code? Boolean true is equal to false and Boolean b is equal to true. Then system dot out dot println of b. What would be the output of this code? Does it compiles or it will not compile? If it compiles, what is the output of this code? Boolean b equal Boolean true equal to false, and I'm saying b equal to true, and then just printing the b value. So the first question is, will the code gets compiled or not? Does the code get compiled or not? Yes, it gets compiled and the output is false. It gets compiled and the output is false. Okay, the reason. Can someone tell me the reason? The code gets compiled and the output will be false. Okay, let us see. I'll give the explanation. I'll try to compile the code again. The code has been compiled. The output is false. So here is the explanation for that. So Boolean true, here T is capital. Okay, it is not a literal. It is not a literal. Literals are when it comes to the booleans. Okay, when it comes to the values, true, false. These are literals, but not capital T or false, something like this. These you can use, but not these. These you can use as identifiers, right? So here I am using true. I am using capital T here. So this capital T is unknown. This capital T, the meaning of capital T is unknown to your compiler or to your interpreter. So it is not a keyword. It is not a keyword. So into the boolean, I am declaring a boolean variable which is called true, and I am passing the value as false inside it. I am storing the value false inside this memory location. Something like this. So this time boolean true equal to false, and then boolean b equal to true, right? Then I'm trying to print b value. So think this is your memory. Think this is your memory. And first, the name of the memory location is given as true. And the value inside is stored as false. Stored as false. Now, there is one more variable which is called b. And I'm trying to copy the value of true. I'm trying to copy the value what is there inside true to the b. So inside the true, what is the value? We have the value as false. So this value will be copied here. So now what I'm trying to print? I'm trying to print b value. So what is there inside b? False. To print false. Because now true is not a literal, or it's not a keyword. It's not a keyword. True is a identifier. It's an identifier because I'm using capital T. I'm using capital T. If I change this to small t, if I change this to small t, now this is an identifier or this is a keyword. This is a keyword or a reserved word which your compiler and your interpreter knows the meaning of it. You cannot use this as a identifier. Identifier means a name of a variable. So now when I try to compile, now you will get a problem. Okay. So it is not a statement. It's not a statement, it says this one. Okay. That's all for now. I'll give some more examples in the as a classwork. I'll give some examples for this where you can identify what is the value inside it. Just try to picturize them, read the concept, understand the rules and regulations, and then you can answer those questions. There are like 10 questions that I'll be giving you today, where you have to give your answers for that on the questions. Okay. So we have completed the variables topic, identifiers topic, and constants topic. In tomorrow's session, we'll see the literals, and then we'll go for the operators, and then we'll go for the control statements. Okay. Thank you guys. Thank you so much. If you have any questions or queries, please send it over the chat, or maybe you can give it to the organization. They can pass it to us, and we will provide the answers for it. We'll have a one-to-one connect, and we'll clarify all your questions for that. Thank you.